Okay, I think we can start. Thank you, everyone, for joining.
All right.
So, hello, everyone. Welcome to join us Zycamp 2024. And our first topic today is about Wi-Fi 7. Okay. Oh, let me check. Okay, so this is the agenda of the Wi-Fi 7 technology. And in the first chapter, we will have a brief review about what is Wi-Fi 6 and the Wi-Fi 6E. And then we'll move on to see what's new in Wi-Fi 7 technology, and also what its core feature like. And then in the second chapter, we will talk about what is release 1 to release 6 stand for in the mesh technology. Yeah.
I think I can move. Can I go up there? Because I can't see it.
Oh, you mean a word?
Yeah.
Oh, yeah, of course. Yeah, of course you can move. Thank you. Yeah. But I need to move all of these.
Sorry about that.
It's okay. Thank you. Okay.
Oh, hey, Will, good morning.
Oh, good morning.
We can sit there.
Yeah, you can see the screen better than I can.
Yeah, because the screen is not so clear, I think.
There's a beverage involved, man.
Okay, so I continue. Thank you.
Yes.
Okay, so in the third part, I will introduce our Zycamp product with you in US market. Okay, so before starting introduce what is Wi-Fi 7, let us have a quick overview about the Wi-Fi technology. And this is a timeline of the Wi-Fi technology. But you can see that the Wi-Fi 5, which we also call the 11AC, was launched in 2013. And this technology is not only extend the bandwidth from the previous 80 megahertz one to the 160 megahertz, but it also introduced a new feature like an NU MIMO, which means multi-user, multi-input, multi-output. And as you can see that before the NU MIMO is introduced in Wi-Fi 5, the previous Wi-Fi 4 technology used a technology called SU MIMO. And SU MIMO, the idea of this one is that like AP can only do the data transmission to one of its stations at a time. But when the new NU MIMO technology is introduced in Wi-Fi 5, you can see that the AP can now able to communicate several stations at the same time because of its new function. Okay, and the other feature that introduced in Wi-Fi 5 is a beamforming function. And with the help of this technology, it can reduce the waste of signal by allowing the AP be able to provide a direction signal transmission to the target device. Because you can see before the beamforming function is introduced in Wi-Fi 5, the AP will spread its signal to all the direction like this. But when the beamforming function is introduced in Wi-Fi 5, you will see that the AP will now able to send out the direction signal to the target device directly like this. Okay, so now we move on to see what's new in Wi-Fi 6. And as we can see that the Wi-Fi 6 is also called 11AX. And the technology was addressed in 2018. And let it have several features listed here. And in the later slide, we will talk about the feature in more detail one by one, and to see what the feature is about. Okay, so the next one is the Wi-Fi 6E. You can see that the name is similar to the Wi-Fi 6, like it also called the 11AX. And the Wi-Fi 6E is a successor of the Wi-Fi 6. Like it only add a new 6 gigahertz frequency band for the data transmission. Because before the Wi-Fi 6 and the Wi-Fi 5, they only have a 2 frequency band, the 2.4 gigahertz frequency band and a 5 gigahertz frequency band. But in Wi-Fi 6, it add a new 6 gigahertz frequency band for data transmission. Okay, Okay, so the next one, which is 2024, we have a new Wi-Fi 7 technology. And we can see that the name is also called the 11BE here. And the feature list here are the core features that supported by the Wi-Fi 7. Like we can see the Wi-Fi 7 also supports the tri-band for data transmission, the 2.4 gigahertz one and the 5 gigahertz and also the 6 gigahertz frequency band. And what's more, the Wi-Fi 7 technology has use 16 spatial streams for the data transmission. And before the Wi-Fi 7, the spatial string used in a previous Wi-Fi technology is only the 8 spatial string. So it means in Wi-Fi 7, it can provide a doubling rate in the data transmission compared to the previous Wi-Fi technology. Okay, and the next one is that Wi-Fi 7 has extended the bandwidth size from the previous maximum 160 megahertz to the 320 megahertz. And the other three are the list three. We'll see them in more detail later, one by one. Okay. Okay, so let's have a quick review about the Wi-Fi 6 and 6E. Okay, so in Wi-Fi 6, the technology introduced a new data transmission called OFDNA. And the reason why the OFDNA comes out is that the design is wanting to solving the previous design limitation in OFDN, which is used in Wi-Fi 5 technology. So before we see what is OFDNA, let us talk about what is OFDN first. Sorry, I need to drink some water. Thank you.
No worries.
Yeah, quite such a long time not talking English for. Thank you.
Yeah.
Okay, so I continue. Okay, so the term OFDN, we can say that is an abbreviation of the orthogonal frequency division multiplexing. And the idea of this mechanism is like to use a full channel bandwidth for a user at once to send out the data. And as you can see from the animation, let the data sending from the AP to the client will only contain the data for a specific client at a time. Oh, let me just show the animation again, like this. Only the data for the specific client at a time. So it means during the period of the data transmission, only the target client can receive its data. And the other devices connected to the AP has to wait until the previous data transmission is finished. Then they are able to receive their own data. And since this design of the OFDN is a lack of efficiency, so that's why the new OFDNA is introduced in Wi-Fi 6. And in order to speed up the data transmission and let AP support multiple clients at the same time, the new mechanism called the OFDNA is introduced in Wi-Fi 6. And the word the OFDNA stands for the orthogonal frequency division multiple access. And the concept how this mechanism works, we can see that it's by dividing a channel into several subcarrier like this. And then the different subcarrier will then be sent to a different client simultaneously, like the animation shows. So since all the client can receive their data at the same time, so when we compare to the previous OFDN, we can say that the benefit of OFDNA can not only help to reducing the latency, but also improving the overall efficiency in data transmission. Because right now, all the client connects to the AP can receive the data at the same time. Okay. Okay, and the other improvement in Wi-Fi 6 is this one. It's about the Wi-Fi 6 using the 1024 QAM for the modularization. And we can see that the term the QUN, the QAM, it stands for the quadrature amplitude modularization, and which is an advanced modularization scheme widely used in Wi-Fi communication. And also we can see that there's a number connect ahead the word QAM. And a number represents the result of a power of 2. For example, we can say that the 256 equals to the 2 power of 8. And the other one in Wi-Fi 6, the 1024 QAM is equal to a 2 power of 10. So, and the number is represent how many bits per second, a bit per symbol could be sent in a single transmission and data transmission. And so when we compare to the Wi-Fi 6 to Wi-Fi 5, we can say that Wi-Fi 6 could provide 2 more bits per symbol in a data transmission. So therefore, it could increase around 25% throughput. But please know that this result could only happen in an ideal situation, because we can see that the space between each dot in a QAM, in a 1024 QAM is much more smaller when we compare to the 250 QAM. And the smaller the space means a higher chance that the interference to happen during the data transmission. So, okay.
There's more margin. There's less of a margin for error the bigger the space is. Obviously,
Right.
like if there's impedance noise, it could take out a bunch of QAMs basically and lower your throughput.
Yeah, I mean the space like this, you can see is much more smaller. Yeah, so that's why the interference has a higher chance to happen.
That's why when you're doing high-speed Wi-Fi, it pays to be like in the same room, for example, because there's such a chance of interference. The farther away you go, the faster the throughput drops.
Well, take this one.
George,
Yeah,
quick question, because we have seen all the improvement from the one of you, right, for
Yeah.
5, 6, 5, 7, no. But not only this has to be like ideal, but my question is more related to what is a mixed flying environment? When you have Wi-Fi 6 and Wi-Fi 5 flying connected to the Wi-Fi 6 AP. Can the AP use a specific QAM setting for the Wi-Fi 6 client and a lower QAM setting for the Wi-Fi 5 client, or it have to be one setting for everybody?
sorry, I think it's a good question, but since I'm not in charge of the CPE device, so maybe I need to double check with our team. Like,
Okay.
yeah. So your question is about like whether AP support Wi-Fi 5 can also support the Wi-Fi 5, AP support Wi-Fi 6 technology can also provide the Wi-Fi 5 connection to the other device.
No,
At the same time.
I know Wi-Fi 6 and
Yeah.
Wi-Fi 5 client.
Yeah.
My question is, if everybody is Wi-Fi 6, so you can use the 1024 one, right? Everybody's happy about
Yeah.
the throughput but what happens if you connect a Wi-Fi 5 client to that network? There have the AP to download to 256 one for everybody because there's a client over there that doesn't support 10.
Oh, okay, got it. Let me write down the question.
Or can be like a hybrid environment that it will use 226 only for the Wi-Fi 5 client, and we'll keep using 1024 one for the rest of the Wi-Fi 6 client.
Yeah, I think that question is quite tricky. Let me write down the question.
I just want to understand if you put a legacy device to that network, if that will mean you will lose your advantage.
Okay.
I don't think we would, but. I don't, because we haven't, well, number one, we haven't seen we lose the advantage, right? And number two is that if you look at the QAM, 256 QAM can go into 1024 QAM pretty easily. It just takes bigger blocks.
And for how we share for it. Because I have asked this question even R&D and they haven't given it. So.
I mean, what-
So far,
No, but-
so far everybody's assuming, but my point is,
But what does
we
it
know,
matter?
do we know for sure?
What does it matter if we don't
Does it
see the
mo-
issue? If we don't see the issue in the field, then why does it matter? Like, whether the question is answered like in a technical, like, you know. Like, if we, I'm just asking, like, have you seen an issue where like you put a Wi-Fi 5 device into a Wi-Fi 6 environment and everybody's like, throughput goes down?
When you sit down with head of engineering, when they design networks, they want to know what is going to be the optimal performance on that network. And that question has come to us from multiple sources.
Okay,
They want to understand if having legacy device will impact the network performance.
but it doesn't, right?
Have you checked it?
I think.
No, but it doesn't, right? Because we haven't seen it in the field.
I think that concern actually.
Yeah, I think you're assuming, but.
I'm not asking, I'm not assuming because we haven't seen it in the field.
Okay, have you checked what is the quantity that you would do? Most of the Wi-Fi 6 router, when you check, at least when I check, you put 226. Have you checked that really on 1024? Have you checked it? I really went to that one. And then you check it after you connect.
Have you noticed throughput like significantly degrade after you put a Wi-Fi 5 device into the Wi-Fi 6 network?
Okay, we can take that offline.
Yeah, thank you for everyone's feedback. Let me write down, check the execute about it. Thank you. Okay, so I move on. Okay. Okay, so the next feature in Wi-Fi 6 is about how Wi-Fi 6 technology do to avoid collision to happen in a data transmission. And as we can see that before the feature called BSS coloring is introduced in Wi-Fi 6. The Wi-Fi technology before Wi-Fi 6 using a mechanism called CSNACA. And the CSNACA, which is abbreviation for the carrier sense multiple access with collision avoidance. And the idea of this mechanism is that the client has to listen and wait until the channel is free, then able to send out their data to the AP. For example, here we have an animation shows like this. Like we can see there are two AP installed in an environment that are using the same channel at the same time. And if we now have two client devices, the user A and the user B are now connecting to the AP at the same time. You will see that while user B is doing a data transmission to one of the AP, the other user A has to wait until the user B is finished the data transmission, then able to send out the data. And since this mechanism is a lack of efficiency, so in order to improve this point in Wi-Fi 6, the new technology called BSS coloring is introduced. And how the BSS coloring works is that the technology marks a shared frequency by a numerical identifier, shows here. Sorry, the screenshot might not so clear. Yeah, but this is a, how to say, it's a result got from the error packet. And the numerical identifier, I mean, is in this color, shows like this. Okay, so now we back to the example here. So we can see that since right now the two AP can support the function called BSS coloring. And the user A and user B in the same environment and now able to send out their data to the different AP. Because right now the user A and the user B can distinguish the different signals sent from the different AP at a time.
This is mostly important when both of these APs are using the same channel.
Yeah.
Because if they're both on the same channel and one user is transmitting, then the other user can't transmit even though he's going to a different AP. So that's why they add this coloring mechanism. So even if they're on the same channel, there's less talk of like cross-channel interference because the users can identify their APs more easily.
Yeah, thank you for sharing. Yeah, it's a benefit of this feature in Wi-Fi 6. Okay, so the next feature in Wi-Fi 6 is this one, the target wake time. And the target wake time can break into a TWT in Wi-Fi 6. And the reason why this technology is introduced in Wi-Fi 6 is that Wi-Fi 6 technology want to reduce the non-essential power consumption of its client devices. In other words, with the TWT feature supported AP, the AP will negotiate the period with its client devices, when and how often the devices have to wake up in order to receive the data. And this design is quite good for the IoT devices, because it can not only improve their battery, because it can improve their battery life as the devices are not always in the standby status. Instead, they can in a sleep status, while the other devices is doing the data transmission with the AP. Okay, so here's an example, like we can see that. Before in Wi-Fi 5, when one of the devices is doing a data transmission with the AP, the other device connect to the same AP has to in a waiting mode, or if we call it standby mode. So these two devices will continually consuming their battery life because they are not in the sleep mode. And when it comes to a Wi-Fi 6 technology today, we can see that the devices are now able to be in a sleep mode. So therefore, they are not required to continue in consuming their battery life. And when the first devices is finished data transmission with the AP, we will see that the second device in this example will now in the transmitting status to communicate with the AP for the data transmission. Okay. Okay, so and the feature of the Wi-Fi 6E is nearly the same one like Wi-Fi 6. But the Wi-Fi 6E technology introduced a new 60 gigahertz frequency band as its third frequency band for data transmission. And we can see that the range of the 6 gigahertz frequency band is ranging in the 6925 megahertz to the 7125 megahertz the range. And if a channel is using the 20 megahertz each, we will see that we will total have 59 non-overlapping channels in this range. And if we use the 160 megahertz as a bandwidth size, we will only have 7 on non-overlapping channel in this range. Okay. Okay, so now let us move on to see what's new in Wi-Fi 7. Okay. Okay, so why do we need Wi-Fi 7? It's because the new Wi-Fi technology has at least 3 improvements when we compare it to the previous Wi-Fi 6 technology. And the first one is that the Wi-Fi 7 can provide the increased data rate of download and upload speed. And this improvement are essential for handling the increasing demand of data-intensive applications such as VR and AR devices, or also the video streaming. And the second point is that it's about the Wi-Fi 7 can provide has a reduced latency when we compare to Wi-Fi 6. And the point about that Wi-Fi 7 has a less latency, like can provide smoother and more responsive interaction with a time-sensitive application. Like we mentioned, like VR and AR devices. And the third one, which I think is the most important point in Wi-Fi 7, is the enhanced spectrum efficiency. And this point talk about that Wi-Fi 7 can now use the available radio frequency spectrum in a more efficiency way. And this improvement is especially crucial in environment with dense deployment of wireless devices such as urban area, office, and public venues. And in a later slide, we will see what's the core feature of a Wi-Fi 7 one by one. And also how the new Wi-Fi 7 technology can enhance the spectrum efficiency. Because that is one of the function, like I think it's a very interesting case for, how to say, to show how Wi-Fi 7 enhances spectrum efficiency. Okay. Okay, so this is the first core feature in Wi-Fi 7. Like we can see, the Wi-Fi 7 use 4096 QAM for the modularization. And as we already know that the number ahead the word QAM is a result of the two power of it's a calculation of the two power of something. So we can say that the value 4096 can equal to the 2 power of 12. So it means the Wi-Fi 6 allow the 12 bit per symbol be sent in a single data transmission. And therefore, when we compare the result with the previous Wi-Fi 6, we can say that the Wi-Fi 7 can ideally provide a 20% increased throughput. But like before, we need to know that since we can see that the space between each dot in a Wi-Fi 7 is much more smaller when we compare it to this one. So we can say that the 4096 QAM will have a higher chance for the interference to happen in a data transmission. Okay. Okay, and the next core feature in Wi-Fi 7 is that Wi-Fi 7 has an increased spatial string for data transmission. And before in Wi-Fi 6, the technology only supports 8 spatial string at the same time. But in Wi-Fi 7, the technology has increased this value from 8 to 16. So it means the technology can result in a doubling of the data rate over Wi-Fi 6. Okay. Okay, and this is the next core feature of Wi-Fi 7. Is that Wi-Fi 7 can make a better use of the 6 GHz frequency band by doubling the maximum channel bandwidth from the previous 160 MHz to 320 MHz. And this benefit means that Wi-Fi 7 can deliver much more faster data rate to many more devices simultaneously. And ideally, the value it can deliver the peak rate of over 40 gigabit per second, which we can say is a 4 times increase when we compare to the result in Wi-Fi 6E. Okay, and the next one is a next core feature in Wi-Fi 7 is a multi-link operation. And this feature is a highly anticipated feature for Wi-Fi 7, like it can ensure the high priority data get transmitted without delay. And there are total 2 kinds of operation belongs to this technology. And this is the first one, the ENLSR. And the ENLSR is an abbreviation of the Enhanced Multi-Link Single Radio. And when using this operation to do the data transmission, it means that our station device is now available on the 2 channels on the APs. And during the data transmission, the AP will detect whether if a channel is currently free, then the AP will use that channel to send the data to the station. And if one of the channel is currently busy at the moment, for example, if channel 1 is busy at the moment, the AP will use channel 2 to send the data to the station device. And if channel 2 is busy, then the AP, because since it has another channel 1, can send the data, so it can use it. So it will use channel 1 to send the data to the station. Okay, so the other one of another technology of multi-link operation is this one. is a MLNR. And we can see that the word stands for the multi-link multi-radio. And when station devices is connected to an AP that supports this mode, it means the client can connect simultaneously on the AP's two channels like this. And the AP will then use the two channels to send the same data to the station. And the reason why this mechanism, why this technology is introduced Wi-Fi 7, because they want to improve the redundancy between in the data transmission to the station device. For example, if one of the channel, like channel 1, has a packet loss event to happen, since the same data will still be sent through the channel 2, so the station device can still able to receive its own data. Okay. Yeah.
On MLMR.
Yeah.
The channels are in different radios, right? That's the main difference with EMLSR. In EMLSR, the channels are in the same band, and in MLMR, the channels are in different bands. That's my understanding. Correct?
Oh no, just because the example showed here, just like to tell the difference between these two technology, because you can see that in E and SR, when one of the AP will not send the same data through the two channels to the devices, and the reason why this design comes out is, and this benefit of this design is that when an AP detects one of the channel is busy or have a high rate for the packet loss to happen, you can still use another channel to send the data. Yeah, that's a design. But in the NLSR, the AP will use the two channel to send the same data to the devices.
And it will be the same band,
Same band.
the same radio.
Like if
You
he's
can
out
Yeah.
do- It says it can be used concurrently to share redundancy or unique data. So it doesn't have to be, no, it doesn't have to be like for backup purposes. It can also be for throughput purposes. So I mean, I guess, you know, like York is talking more about the redundancy right now.
Oh yeah.
But it actually
Second
says
case.
like unique data as well, so, you know, if we're sending unique data, then it wouldn't be like, on both channels, it'll be 1 through 7 and then like 8 through 14 or something like that.
But the point is, if in one we're using one radio, and the other one we're using two radios.
Yeah,
It's my
single radio
understanding.
versus multi-radio.
Like you say, it can be
Yeah.
used for extra throughput or for redundancy.
Right.
But the main difference, and my understanding is that one use only one radio and the other use two radios. Or more than two, actually can use three radios.
Right, well, I mean, I think that this is not the only, slide on the, MLO, right? There's another one coming up. York,
You
what's the
mean?
next slide?
Oh, this one about multi-IU puncturing.
Oh, okay.
Yeah.
Hmm.
Yeah, but I think ML, that multi-radio is something that you set up that demo for.
Right, because, when we set up MLO with the Wi-Fi 7 device for CES, you know,
ML.
we're bundling like the 5 gigahertz and 6 gigahertz band radios.
Yeah, it
We
was
send the throughput
direct,
to, you know,
it was direct RF radiation, like they had the two radios wired to each other with the RF cabling, so we were doing full MLMR on 3 radios, basically, getting.
so that's why,
Freaking gigs.
Carlos is asking, is that when we're talking about bundling, you know, channel 1, channel 2 together, he's saying that it's actually 2 separate radios.
And in the case of MLR,
I think you're right, because those texts are highlighted in both, there's actually mentioned that one is single radio, the other is
multi-radio.
like multi-radio. So yeah.
It already says multi-link, multi-radio.
Oh yeah, sorry. I think the reason why it shows a single radio is I only use one of the channel to send the data. So that's why you say single radio. And here you use multiple radios to send us data. So that's why you say
Yeah, so
multi-radio
it's not
here.
just 2 radios.
Yeah.
It's multi-radio.
Yeah, this is just an example for the demonstration. Okay. Okay, so this is last core feature in Wi-Fi 7. It's called a multi-RU and puncturing. And the concept of this feature is by using a multi-RU segment unit to segment a wide channel bandwidth into several small units and enable a puncturing of the channel. So it can be used without conflicting incumbent signals, particularly in restrict portion of 5 and 6 gigahertz bit. And since the description they showed here is hard to understand, so here we have an example. And assuming we have a bandwidth using 160 megahertz for data transmission. And today we suddenly, this channel suddenly encounter a 40 megahertz bandwidth that was kept for the DFS use. When such event happens, it will make the whole channel become unusable because the 40 megahertz channel is capable for the specific use like military radar or a bandwidth satellite communication.
Yep. That's what DFS is about.
Yeah, there's a definition of DFS. And so in order to slow it, because before in Wi-Fi 7, when this event happened, it will make the whole channel become unusable.
You mean Wi-Fi 6, like if you do Wi-Fi 6, the whole channel.
Yeah. So that's why a Wi-Fi 7 introduced a function, because they want to slow this situation to happen. Because we can see that when this feature is introduced in Wi-Fi 7, the devices can still use the rest of the remaining 120 megahertz to do the transmission. So that's why this feature about. Because the devices can still the remaining bandwidth for the data transmission.
Yeah, when you're using 160 megahertz and above, basically.
Yeah.
So if you start using ultra wide, like the 320 megahertz channels in Wi-Fi in the 6 gigahertz band, you don't want to cut off the whole band. You can just use the rest, basically. Smart idea.
Yeah. Yeah. So I also think this mechanism is quite interesting in Wi-Fi 7 as well. Okay, so this is a comparison table for the Wi-Fi 6 and 6E and 7. And aside from the name, like using Wi-Fi 6 and 7 is different, we can see that, and also the Wi-Fi 6E, both Wi-Fi 6E and Wi-Fi 7 support the tri-frequency band for data transmission. We can see the difference that the Wi-Fi 7 uses 16 spatial string for data transmission, but in the Wi-Fi 6 and 6E, they only use a data spatial string for the transmission. And also, we already know that the quantum modularization using the two technology are different. That Wi-Fi 7 uses 4096 quantum, but in Wi-Fi 6 and 6E, they only use 1024 quantum. And also from the perspective of the transmission rate, we can say that the transmission rate, max data rate in both technology are different. That Wi-Fi 6 and 6E can, the maximum data rate in Wi-Fi 6 and 6E can almost 10 gigabits per second. But in Wi-Fi 7, we can say that the technology can provide at least 30 gigabits per second in the data rate. Okay, and the other ones, okay. Also, the Wi-Fi 7 technology has increased the bandwidth size from the previous standard, the 160 megahertz to the 320 megahertz. And the security mechanism using a two technology are the same, WPA3. And below the other summarize of the new technology introduced in the two Wi-Fi. Okay. Okay, so let's move on to see what's the new in the mesh technology in this chapter. Okay, and this is a timeline of the mesh technology. We can see that right now, the mesh technology as a sixth generation, starting from release 1 to release 6. And so far, all Zycamp devices support releases at the moment. And also, the release 6, we need to know that the release 6 still a draft at the moment, because the Wi-Fi Alliance hasn't released a formal document for the ECMAT release 6 yet. Okay, so let us have a quick view about what is. Oh, sorry, it's not so clear actually, but I think you can still understand the word shows here. Okay, so let's have a quick view about what is release 1 and release 3 stand for in mesh technology. And in the release 1 of the mesh technology, the Wi-Fi Alliance define a fundamental and common mesh network framework. And also, they define the diagnostic ability of monitoring the connection capability and the transmission performance between the mesh devices and stations. And the third one is that they also define a steering behavior that the wireless APs will always check the connection quality and the performance of a station. If the devices find a station, it has a weak signal, it will then ask the stations to steer to another mesh devices that can provide a better connection quality. And the third one is about optimization. And this point is to talk about that it can optimize the network based on frequency and the signal stress status. Okay, and in release 2, we can see that also the release 2 also has a 4 point as well. And the first one is a standardized Wi-Fi diagnostic. And the point is about that the release 2 standardize a Wi-Fi diagnostic function to make it a standard and improve the device management for several providers. And the second point is that it's talk about the enhanced client steering function. And this point is to talk about that it has an enhanced client steering by merging network resource and increasing mobility for better user experience. And the third one is called a traffic separation function. And the idea of this function is by using the VLAN technology to split the ghost Wi-Fi traffic and ghost traffic from the home traffic for safety concern.
Separate what traffic from home traffic?
Guest, how to say?
Yes.
Yeah. Sorry, my pronunciation might not correct. Yeah. From home traffic, and using a VLAN technology to do that.
That's part 2. So
Oh, yeah,
we're
they
already
released
past
it.
R2.
Yeah.
No, but
Oh yeah, our device already support R2.
Yeah, we're already.
The first multi-pro, you remember, didn't have separation.
Yeah.
So that's something we got
Yeah,
later
easy, like.
in multi-pro.
Fair enough.
Okay.
In Pro Mesh, yeah, we got it in Pro Mesh.
Okay. Okay, so the last one in release 2 is a coordinate CAC. It's this one. And with this feature, it can coordinate all AP to scan the DFS and the wireless bands to avoid a new DFS event to happen. And as we already know that the DFS is represent a dynamic frequency selection, and which is a function of using a 5 GHz frequency band, like a generally reserved for them. Service like a military radar or the weather radar or the satellite communication. Okay, and now we move on to see what other features in release 3. Okay, the first one is about the network capacity. And this point is it asks the increased network capacity to support more simultaneous service and higher relay throughput when operating in Wi-Fi 6 and Wi-Fi 6E. And the second one is to talk about the service prioritization. And the concept it's like a steering mechanism we introduced in release 1. But it actually asks the devices can have the capability to prioritize the low latency application and guide the device to run to the best connection in a matchstick topology. Okay. And the next one is about a Wi-Fi Easy Connect. And the points that talk about that users should be able to connect the Wi-Fi devices easily by scanning the QR code on the backside label of the devices. And then the AP will then should be able to guide the user to join the current network mesh network automatically. Just scanning the app label on the just scanning the QR code on the backside label of the devices can do that. Okay, so the last one is about 1905 layer security, and which means all the traffic between the 1905 layer is secure among all the mesh devices. And for the detailed information, what is 1905 layer? Please refer to the material shared by Current in Zycamp 2020. It has a detailed explanation about what is 1905 layer. Okay. Okay, so now we move on to see what are the essential point raised in release 4. Okay, and we can see that the point mentioned in the release 4 has at least 3. The first one is about enhanced Wi-Fi 6. And it means it makes a mesh network be able to deliver faster data rate transfer rate and lower latency, like Wi-Fi 6. Okay, and the next one is a diagnostic and remote management. Like the actual vendor should to provide a mobile app or other compatible devices for diagnostic and remote management purpose. And the user should also able to use the app to control their network and or monitoring devices or do some troubleshooting work with the app. And the third one is this one, the traffic tuning and the shaping. And the traffic tuning is a feature that management of flow or network efficiency, management flow of network traffic by prioritize certain type of data over others. And the other one, the shaping, is that the shaping is a technique that can limit the speed of traffic to a certain level. Okay. Okay, so this is a point mentioned in release 5. Like we can see, it also have a 3 point as well.
Yeah, I already know down.
Yeah.
Yeah, I'm gonna have to ask Tino for a vacuum because I dropped it earlier.
Hope you
Oh, wow.
enjoy it.
Holy moly.
Yeah.
I mean.
Carry on.
Oh, okay. Okay, I carry on.
It's good though.
Yeah.
Yeah, quite sweet actually.
Worth the mess.
Oh, definitely.
Yeah, but that one is a Chinese, how to say,
It's-
typical Chinese snake. Yeah.
Thank you.
Yeah, I'm hoping Tino's got like a handheld vacuum or something, but at some point I'm gonna vacuum this up.
Yeah, I want to share this to Dino as well. Is he in the office today? I haven't seen him.
I haven't seen Dino.
Dino is connected, yeah, he's still at the PM council. They're doing
Oh, okay.
Day 3 of sales alignment.
Okay, so maybe I go to find him later and share the snack
No,
with
you
him.
just leave it on his desk.
Oh, okay.
I'm not interviewing him.
Okay, so the first point in release 5 is about WLAN QoS management support. And the point is talk about that the release 5 introduced a WLAN QoS management support such as a DSCP or a QoS map. And the second one is called the virtualized BAS for multiple AP coordination. And this point is a technology like enable multiple APs to work together to provide a seamless Wi-Fi coverage across larger area. And the last one is about the station's access control. It means right now in release file, it can make the mesh network controls access to specific site, including blocking or authentication become possible.
I don't understand the virtualize,
Yeah.
the explanation for the second, because that's the
That
point.
mesh is full already, right?
Right, I mean, that's the point, that's the purpose of mesh,
Are we
right?
talking about two like
I
different
think probably to
geographically
this very
disparate?
network.
We're talking about two different places, like between like a home and an office, for example, or?
How to say?
I mean, isn't that a
Yeah, yeah,
description
yeah.
for mesh?
Yeah, actually, it looks similar. But I think maybe they talk about more in other phases, like providing higher speed or larger. How to say?
Yeah, I mean,
Yeah, maybe an enhancement to say that.
Maybe it helps with enabling those features you were mentioning earlier from the Wi-Fi 6 with the multi-radio link and a single radio channel,
Like
with the bit rates.
So like the wording virtualized BSS, that just sounds fancy.
We're gonna
Hmm.
put it in that so I can look it up later.
Yeah.
Yeah.
So maybe we can wait then to develop a feature first, so that we can realize what exactly about. Thank you.
I mean, we have this, right? R5 we're currently.
No,
on,
no,
and
our
Pro
device
Mesh
currently support R2, release 2 only. So,
Release 2 only.
yeah.
And Pro Mesh is on release 2 right now.
M Pro Mesh. You mean the app? The
That's
M
for
Pro Mesh.
Wi-Fi 6 and Wi-Fi 6.
Wi-Fi 6 is supposed to be really hard to find.
But from information I got from it, let's say,
Wait, what?
yeah.
What version of mesh are we using right now? What, in the, EX 7710, you know?
Sorry, I haven't know such information, but from the information I got, let's say it's a release 2 at the moment. Yeah.
Matches what I saw yesterday. PM counts, to be honest.
What?
You know, you mentioned R2
We're on.
Yeah, release 2.
So,
was a high number by the.
Yeah.
So, okay. Are there plans to upgrade?
Is R5 still proof of concept right now? Or do you have some form of like,
For you
No,
mean?
R5 is, from the previous slide, R5 is
Yeah.
already approved, R6 is.
Oh, yeah. R6 is still a draft at the moment. X3, yeah. So the 3 point I list here just feedback update shared by our RD team based on the current draft of release 6. Okay. Oh, okay, so I carry on. Thank you. Okay, so we can see that the update shared by our RD team about release 6 also have a 3 point here. And the first one is the data element R3 support. And the point to talk about that the release 6 adding more TR369 and TR181 parameter and object in this new release. And the second one is about a Wi-Fi support feature like a basic multi-link operation and a static pointering. And this feature, as we already know, is quite a core feature in Wi-Fi 7. And the last one is a QoS management for R3 support. The point to talk about that the Wi-Fi device should support the QoS management from the release 2 to release 3. Okay. So now I move on to introduce what the roadmap of our the model we promote in US market.
Yes.
Okay.
Yeah. Okay. Okay, so for the US market, here are the model we promote. And then right now, we can see that we currently have at least 4 models for the SGS phone devices available. And also in the soon Q2 of 2024, we'll have a new Wi-Fi 7 supported HDU devices with a name PE6601.
This is a project base
Oh, it's a project based.
for us, yes.
Okay. Oh yeah, because it's for US market.
Right, for projects only,
Oh, okay.
not for general
Like
sales.
tier 1 projects, tier 2 projects, not for like OBM or tier 3.
You know, we're not carrying it unless somebody's like gonna buy it for the project.
Okay. Okay, so and also we can see that we are now planning for 2 other SFU models. In the future, maybe they will release in the 2025. And one of the model we can see that it can support up to a 225 gigabits in a LAN port speed. Is this one?
Cortina or Aroha?
Those are Cortina based, but are we moving away from Cortina? That's what they told me.
Yeah, we may be moving away from Cortina.
What is the difference between the 7518 for the?
Oh, you can see that 7518 only a 10 G LAN, but this one has a 25 G LAN.
No, 7518 to the 7516, what is the?
7560.
Definitely they can't support, from what it looks like there, it can't support the 10 gig. It doesn't have-
Yeah. And also you remove the VoIP interface here.
But it's also got
10 gig.
It also-
7516 has 10 gig LAN.
Yeah, I just saw that right there. But
Because that's why when you told me that, no, because we used it for 10G, like.
yeah,
demo.
yeah.
So,
7516
so is it just an updated chipset maybe?
Could be.
So that means that the 7516 is probably gonna be EOL after the 18 comes out?
7518.
Could be.
It could be Aroha also if it's not.
But 7518 doesn't have Wi-Fi in there. 16 has Wi-Fi in there.
Yeah. so it's-
Well, we have a 7510 as well.
Yeah, like the 7300 is 7510 right now.
Right, so the 7518 is replacing the 7300 then, it looks like.
Yeah.
Yeah, it looks like the model is a successor for this one. Yeah,
Alright.
but maybe we can wait until they final formal, how to say, finalize the specification of this model, because right now it's still in a planning status. Yeah. Okay, and for the GPON model, we currently have a list A available for the US market. And also we can see that we will soon have devices, GPON HGU devices that can support Wi-Fi 7 in 2024. Also, it's I think it's how you measure.
I don't.
Yeah, it's a label. We can
That's the
see.
chipset,
Yeah. Okay, and for the home connectivity product roadmap, we also will soon have 2 other models. One of the models can support Wi-Fi 7. And from the information they share, it's supposedly we can have it in the Q2 of 2024.
There's also the 6601, which we know has the FXS ports in it, and it has a built-in SFP bay. So 6510 is gonna be more like the 7710. It's not gonna have the FXS ports, and it's not gonna have the SFP bay. It's just gonna have 10 gig Ethernet WAN, and then your 4 ports. One of which is gonna be a 10 gig port for through testing.
Oh yeah, 10 G port. Okay. Okay, and for the DSL models, we currently have at least 7 available. And it looks like we currently have no plan for the DS model in 2024 and 25.
No,
Yeah.
DSL is,
Yeah, DSL is like going up a little bit, isn't it?
yeah, we'll be carrying the 4927 and the 4510. But we don't commonly carry the 5510. And 3927 is EOL. And,
We're gonna keep the VMG 405.
and we don't use those other two. We don't use the DX 3100 or the VMG 8623. I've never seen those in the US market.
Hmm.
Those are on the South America, but like it's managed under Allen too, that's what they market America.
It makes sense because they're Shiro Rohan products, seemingly
That's
anything.
South America.
Well, for
Urgent market.
financial point of view, they're saying it's the same.
I'm joking.
I thought maybe that guy from Mexico was gonna be here for this.
No, it's more business side.
Oh, okay, fair enough. So anyhow, yeah, that's the plan. We'll still carry the 4005 as a basic bridge and the 4927 and the DX 4510. The DX 5510 was project-based. It never really took off here. We didn't have too much uptake on like a bigger box like that. And then 3927 is single line. It doesn't do bonding, and I think the chipset's being discontinued by Broadcom, so that one's gonna fall off eventually.
What do you do with a bunch of customers that, let's say, have the 4927? What do you do with their?
We'll still-
They'll still continue to
We're
use
still
it.
making the 4927 until we run.
Well, let's say it does go out one day, what would you do? Do you tell the customer, hey, there's not gonna be any support on this, we're not gonna?
I mean, we're not gonna worry about it until we actually EOL it, like.
Well.
Oh, yeah, like Taiwan. Bring from Taiwan.
And,
I mean,
Yeah.
Yeah. And-
So, the point is, like, there are ISPs who only have copper and will continue to serve them with these products.
Well, copper's kind of going out all over the place.
Yeah, I mean, we understand that, that's why we don't have any new
Yeah,
products. you know.
that's why it's not gonna continue.
What will happen
past
with
this.
copper is that they're gonna go with the 4005.
Yeah.
You have to use
Yeah.
bridge because there will not be any
Wi-Fi,
other Wi-Fi investment.
Yeah, in fact, Windstream's starting to do that right now. They're pairing the 4005 with Ethernet routers, basically.
They will have to use the bridge and then Ethernet router. Whatever. from them.
Yeah, so basically they're using the 4005 as an unmanaged DSL bridge.
The transport for 4005 is what transport, what?
ADSL or
No, it's right
ADSL.
there, the bridge one in the bottom.
In the very bottom one right there.
All they have to do is get a Ethernet router and connect it. to
Yeah.
the LAN.
4005 has the same DSL capabilities as any of these
Yeah,
others. It's
but on the DSL.
ADSL2 with ADSL2 plus fallback.
Hmm.
So it'll do everything. It'll do bonding too.
And
4005.
the US market is moving to a two-box configuration.
A lot of people are. I mean,
Right
especially
now, so
with
it won't be
fiber.
new, but-
I mean, their internet service is not gonna change for copper unless the ISP like reinvest.
Runs a fiber out.
Or whatever.
Use that,
But,
some of that.
so
cap
the
market.
customer, if they still want to take advantage of like, better Wi-Fi, newer technology, they have to go with the two-box solution.
But many of the DSL provided what they're saying, in DSL, I can just give you 100 meg or 50 meg, so why I need Wi-Fi 7 or
Yeah,
Wi-Fi 6?
yeah.
So that's their argument that they
I
need to
mean-
move forward, right? But at the moment, they keep leaving behind, right?
Yeah.
Because it's too
Hmm.
expensive to keep it up running. The competition coming up with fiber is eating up their customer base.
Yeah.
And the government give you free money.
Yeah, to lay down fiber, why not do it, right?
The one that really fight it will be forced to use the bridge DSL unit, but at the end, I think everybody will take the money.
Yeah. It's just a matter of time.
We'll sell those 4510s through Windstream as long as I can. Yeah. So, I mean, we still have vested interest in it, but like chipset manufacturers are just not making many DSL chips these days. And that's what it's really gonna come down to in the end, is we're have to end of life it because frankly, after a while, we won't be able to get those chips anymore. So we'll be able to build what we have and then that's it. That's what happened with the 66, with the P660HN. We built those things for like a decade, but then we had to stop because So they stopped making the chips for them.
Well, it also depends on the market too, like, what kind of people are they serving? You know, not everybody needs like, 1 gig, input.
Yeah.
It is true.
Definitely, the
seriously,
market, market will dictate. the
Like, I mean,
situation.
I mean, that's why DSL still even alive. 'cause
Well,
people
think
don't
about
need
it, if
that.
DSL
I
dies,
mean-
then you go with fixed wireless.
Videotron got our Wi-Fi 5 product in 2014, they still have 300,000 units in the field.
Yeah. The
You know,
39
300,000 units, 10 years old.
Yeah, the EMG 29, 26 or whatever it's called.
Ridiculous.
Yeah.
Like they got so much money out of that
Yeah.
device, man.
The ROI on that thing was ridiculous, yeah. It was-
That's why I keep asking if we have anything else for those. Like we spent, yeah.
Well, they might start buying 3510s and.
They made more money from that product than we did.
Yeah.
Seriously.
Yeah,
bottom line.
yeah, product life that
Yeah.
use.
And we had to tell them, yeah, we can't support it anymore because there's no money in it.
Like, how often do you hear like, there's 300,000 units on a 10-year-old Wi-Fi product, like,
Yeah.
still being like.
At one point, we were like, yeah, you'll have to pay us for more support because the money ran out years ago.
Like that one company that I have that always asks, like, oh, are you guys gonna EOL the P660? And I'm like, yeah, it's been dead.
Yeah. It's been dead for like 15 years.
It's not like we will. It was done.
It was done years ago, my friend, I'm sorry.
What's the next slide?
So, yeah.
It's okay. We nearly finished this topic.
Okay.
So just talk about the Wi-Fi 7 product.
We'll
Okay,
bring it later
so
on the schedule.
yeah, here are the Wi-Fi 7 product we have on the road. And the models at least on the page can provide a 10G LAN traffic, at least two. And the list 4 model shows here can only provide a 2.5 gigabits in a length data transmission.
Yeah.
Yeah. And also you can see that.
You'll get the slide later, Steve. Just to let you know.
Oh yeah, because
You don't have to take
not
pictures
clear
of it.
actually.
Yeah,
Yeah.
you don't have to like,
Yeah, and only this.
unless you're trying to sell it for like, to another company.
The thing is that there's gonna be a test. And I've got all the answers. I'm like, oh.
Oh yeah, we'll have a test tomorrow.
Well, it's an
but
open book test.
They open to. I will show you the slide today and tomorrow.
Do my slides and I go, answer.
Yeah.
You guys are flipping through
The pages.
and pages of this.
Oh, so.
We appreciate your honesty.
Yeah, we'll have a bigger screen on our laptop to look at.
Yeah. No worry about that. Like question answer that is not so difficult.
I hope you take good notes because you guys are gonna have an awesome test here at the end. I got my slides.
You will have multi-screen, so.
Wait, can you go back to the previous slide?
Oh, this one?
Okay, so yeah, now pay attention because the BE is like a gateway and then the other one.
Oh yeah, this one's the gateway. Yeah.
The other ones are extenders. I'm not sure which extenders. We probably have the 3300. I'm not sure about the 44. But yeah, we will have 4400. And then
And then for the 6 one.
I'm not sure.
This
about-
one's also the access point.
No, pay attention because there's definitely MediaTek, Broadcom, things like that. One of the other things you'll note is they're all 2.5 gigs. In fact, like you won't see any more 1 gig only products. Everything's gonna be able to support at least 2.5 gigs, at least on one of the LAN ports, if not all of the LAN ports, because access is going up, costs are going down, so 2.5 is almost as cheap as 1 gig these days, so.
Oh, man, I mean, that we have to like upgrade our laptops like adapters.
I was already like looking at stuff for like one of my friends for a new like router, and most of the ones I was seeing, most of the ports are 2.5 on most routers that are like even 50, 60
Yeah,
bucks.
you'll need a
What, you
wide,
mean all of them, or just one?
All
No,
the
all
LAN ports.
all the LAN ports, yeah.
That's impressive.
For 50,
because-
For
$60.
like the TP-Link's got like a $7
telling you,
one
it
at
costs you
2.5,
2.5,
2.4 or 2.5, the LAN ports on them. I have the router at home because I had used it in another house.
Yeah,
that I
no,
had.
no, what I mean is I wonder how good is the performance, because the chipset vendor is and the CPU is not.
I don't think it was,
designed for
I never used the Wi-Fi, so I don't know how good it was,
No, I mean,
but the LAN
LAN
port
port.
itself, the LAN port was decent.
TP
I didn't have any issues.
Link's Wi-Fi like stuff.
Yeah, but I'm referring to the LAN port because many of the chipset vendors
All the
say that
same.
LAN controllers on the CPU. They say the controller is still built for 1 gig. So when you put all 4 into the 5, you can overload the CPU.
Yeah, I didn't try all 4, honestly. I didn't have like 4
Oh, you,
different.
you didn't have a separate switch?
No,
switch
no, no,
controller?
Obviously.
they're working for that.
I-
They
obviously
say
we
that's
do that.
coming late 2025.
I only used it for
2025.
like two devices.
Which system vendor is it?
All of them, Broadcom, Iroha. I don't know about Realtek.
Yeah,
but
the
Broadcom,
The
Iroha.
TP-Link router I have was like, I think it's $80 something, and all the ports are 2.4.
We'll just have to be careful going forward, because this new wired and chipset, we wanna make sure that things still work, like, if somebody needs like an interface group or something like that.
But I didn't think about trying,
Yeah, that might be-
trying all the ports in one go. I
That's
only had my computer, my desktop was the only thing ever connected to.
And when we get new
Yeah.
laptops, we'll have to make sure they can support either 2.5 or like USB 3, where you can use like 2.5.
Oh, yeah, and the occasion whenever I took a device home from here was the only other time I had another device connected.